This lesson will teach me to factor a trinomial into two binomials. This lesson is going to teach you to undo the double distribution or Punnett square process that you learned in the first half of the unit. You've been working on these product sum circles, and here's the connection that they have to factoring. If you look at this particular problem, it's kind of teeny tiny right over here. If you were to take that problem and multiply it, x squared plus 5x plus 3x plus 15, you'd get the value x squared plus 8x plus 15. This, so far, is what you've done. You've taken two binomials and you've multiplied together to get them a trinomial. Well, in this particular section, because we're factoring, we're going to undo the multiplication process. So look at the problems below. Notice the problem is now the trinomial, and the answer is going to be your binomial. So the connection to the product sum circles you've been working on. Oops, I wrote a 5, that should be a 15. Look at the 8. See the 8 in the product sum circle? Look at the 15. See the 15 in the product sum circle? If you think about how you were answering these product sum circle problems, is you were taking the 15 and you were saying, well, what multiplies to give me 15 but adds to give me 8? 3 and 5. That 3 and that 5 are the values that were in the binomial. So here's what you need to write down in your notes. Connection to the product sum circles. The number in the top of the product sum circle is always going to be the value of A times C. So this here is your A value. This here is your C value. Think about the numbers or the letters A, B, C. So the value up top is always going to be A and C. For the purpose of Algebra 1, A will always be 1. This value that goes down here in the bottom, which is the number that you're saying what things add to give me this number, is going to be that B value. So what we need to do here is we need to take our trinomials, put them into the product sum circle, and that's going to be an aid, an organizational aid, to get us to the two binomials. Let me add one more thing, or make you note one more thing. We're factoring things that are in terms of ax squared plus bx plus c, but that value of a is always going to be 1. So again, there's your a, that value here is your b, and there's your c. So I'm going to do that one more time down here. There's my a, there's my b, there's my c. So the product sum circle, things that multiply to give me that c value, but things that add to give me that b value. Well, what answers would you put on the sides of the circles? Well, I know that 5 times 5 gives me 25, but if they were both negative, then it would add to give me negative 10. So the two binomials, what two things multiplied together to give you x squared? X times x. Well, what was multiplied together to give you 25? Well, the negative 5 and the negative 5. Because when you did the double distribution, you had x squared minus 5x minus another 5x, that should be a minus, plus 25. It's because of that addition here that gave you the negative 10. So again, the perfect of the product sum circle is to organize your numbers so that you're able to figure out what things were multiplied together in order and what things were added together to give you the values that you need. So let me kind of rewrite this one a little nicer. The 25 went up top, the negative 10, we came up with negative 5 and negative 5, so my answer is x squared, not x squared, x minus 5 and x minus 5. Make sure they're side by side as they are being multiplied. All right, for the next one, you're going to put the values that you need in the proper spots in this product sum circle. So you're looking for things that multiply to give you 20, as 20 is that a times c value, and add to give you 21. Well, 20 times 1 multiplies to give me 20, and adds to give me 21. X plus 20 times x plus 1. If you were to double distribute, you'd get x squared plus 20x plus 1x plus 20. So when you combine like terms, there's your 21. So these are the two binomials that were multiplied to give you the trinomial. Let's do it again. Things that multiply to give you 18, because 18 is that a times the c value, a, b, c. A times c goes up top. Negative b, negative 11 is your b value. What multiplies to give me 18? 9 and 2, but when I add them, it has to give me a negative 11. So if they're both double negative, x minus 2 and x minus 9. Some students are going to ask, can the order be reversed? Absolutely. As long as you have a minus 9 in one and a minus 2 in the other. Remember, multiplication is commutative, that regardless of the way you multiply two values, you end up with the same answer. Letter D. This is always a little deceiving, but there really is a 1 here. So for my product sum circle, the negative 56 goes up top, and the negative 1 goes here. You're looking for two numbers that multiply to give you a negative 56, and they're going to have to be side by side on the number line. Let's see, a negative 56, one of these has to be negative. The 8. When I multiply these two numbers, they give me a negative 56. When I add these two numbers, they give me a negative 1. So x minus 8 and an x plus 7. And again, regardless of the order that you write them, it doesn't matter. As long as you have a positive 7 in one location, and that should be a minus 8, even though I know it doesn't look like it, in the other location. All right, a handful of these are referred to as special. And I bet it's that way because they were special when we multiplied them together as well. All right, so let's look at these two special ones. And we've actually already done one in the 4 that we did above. You're still going to apply the circle. Things that multiply to give you 36, that add to give you negative 12. Things that make 36, 6 and 6, and if they're both negative. The reason why these are special is because the same thing was written twice. Do you remember seeing problems that looked like this? They're both right, regardless of how you wrote it. And the same thing for up here. But they're referred to as special because this one was a perfect square trinomial. It was a perfect square trinomial because when you did the double distribution, those two terms combined every single time, giving you the negative 12x. These were one of our special cases that we had the shortcut for. And that shortcut is backwards, works as well backwards as it did forwards. This problem is a little deceiving because you feel like you're missing a term, and you are, so it's really just a 0. So the things that make the top of this circle, things that multiply to give you a negative 54, but add to give you a 0. Well, 8 and 8 make 64, and to give me the negative 64, one has to be negative as well. So it's x minus 8 and x plus 8, or vice versa. But if you were to double distribute these, the minus 8x and the positive 8x would cancel every single time. This is what was referred to as a difference of two perfect squares. We recognized that pattern, and you guys were able to figure out that that was 0 and to get you back to your original pretty quickly. So the same thing, if you recognize this as a difference of squares, it's going to help you find the 1 plus and the 1 minus. Couple, and these are labeled as harder. The reason why this one's labeled as harder is more because it's weird. Students get thrown off because we have an x to the 4th and an x to the 2nd, but approach the problem the exact same way. Things that multiply to give you 5, that add to give you 1. Nope. Things that multiply to give you 5, that add to give you negative 6, because it's always that AC value up top and the B value on bottom. A, B, C. The x's haven't played into any of your other product sum circles, and they're not going to here. They just kind of affect what goes in the final parentheses. All right, so things that make 5. Students always say 2 and 3, but 2 and 3 add to make 5. We're looking for things that multiply to make 5. How about 5 and 1? And in this case, they both need to be negative. So far in all the problems, you've taken your answers and you've written them this way. because all of your problems so far have had an x squared, meaning x times x gave you x squared. Well, now I want to know what made x to the fourth. X squared times x squared gives you x to the fourth. The next question that students ask is, well, where did the x squared come from in the center? Take a second and multiply this out. So x squared times x squared is x to the fourth. That's going to give you a negative 1x to the second, a minus 5x to the second, and a positive 6. So that center term, that minus 6x to the second, came from when you were multiplying by those x squareds. This is still your answer. Think about this as your step to check your answer. And yep, it matched my one over there. Let me erase some of this stuff for you so we can go on with the next one. This problem looks strange because I told you for the purpose of Algebra 1, this a value is always going to be a 1. So what a lot of you are going to start doing is, if you know it's a times c, you're going to put a pretty big number up here from your a times your c value. But hold on for a moment. Look at the 3, the 24, and the 60. Don't those numbers look a little big compared to the ones we've been dealing with? The fact that this a is still even here and it's something other than 1 is going to be a clue that you have a greatest common factor to take out. And I bet it's a 3. If you could divide each of these by 3, you'd be left with x squared plus 8x minus 20. Now when you go to do your product sum circle, the values are much easier to work with. And now your a value is a 1. So we have a negative 20 on top and a positive 8. Things that multiply together to give me positive 20, or I'm sorry, negative 20, but add to give me a positive 8. Well, these two do, but this one has to be positive and that one has to be negative. Yep, multiplies to give me a negative 20, adds to give me a negative 8. The 3 is still here. Then you have your x plus 10 and your x minus 20. So picture, you'd have to multiply these together first and then take your answer and distribute the 3 by everything in your answer to get back to the original. So this entire thing are the factors that were multiplied together to give you 3x to the second plus 24x minus 60. Again, students will kind of ask, well, do I need to put the 3 here? Yes, because if you don't have the 3, then you're not going to get back to the original answer. If you leave off the 3, you're going to be left with this problem. Oh, I think that should be a 2. There we go. Which isn't what was typed originally. You need that 3 to get you back to the 3x squared plus 24x plus 60. So your answer is this whole thing. Notice the great big box. Okay, what does it mean to be prime? Yes, it means that numbers have a factor of 1 and itself. It also means that when you look at it from a lens of greatest common factor, can't do greatest common factor. You say, okay, well, what about grouping? I know how to group, but can't group. And the other thing is when you go to look at this product sum circle, and you say, well, I've done the product sum circle and it doesn't work. So let's look at some examples. Look at a problem like x squared minus 12. Can't do greatest common factor, can't do grouping. Try the product sum circle, it won't work. This one's going to be prime. If you look at a problem like x squared plus 7x plus 30, all right, well, things that multiply to give me 30, add to give me 7. You can mess around with these values all day. You're not going to find any two things that when multiplied together give you 30 and add to give you 7. It's prime. Can't group it, doesn't have 4 terms. Even look at to the third, and I am making these up. They're not anywhere in your notes, you just write them down as examples. Can't do GCF. Product sum circle doesn't work because it has 4 terms. Okay, so I'm going to group it, and when you go to group it, find out that it can't be grouped. It means that it's primed. Or it means that it's prime. Prime is reserved for when you can't factor because there's only a factor of 1 in itself. Thanks so much for watching. Please let me know if you have any questions.